Hello, everybody. Welcome. Thank you so much for coming. It's really an honor to speak for you all. So, like he said, I am an engineer for LinkedIn. And LinkedIn is going through this interesting transition right now as a company where we're going from a smaller company.
Wait. You're not amplified.
Oh, what? Sorry?
I don't think people are that. Is everyone here?
Oh, here? Is that better? Here? Is that better?
Yeah.
Okay, let me try that again. Okay. All right, so I work for LinkedIn, and nope, not on. Okay. You're throwing off my groove, man. Off. No. Halt. Somebody else know that? I'm just an engineer. I don't know how to work these.
Sorry. Hello. You can hear me? Hello. No. Hello.
All right, I'll just talk really into this. Okay, does that work? Okay. All right, let's try this again. Hi, everybody. Anyway, LinkedIn, transitioning from a smaller company where all of our engineers and technical folk are in one location in Mountain View, California. And we're transitioning to be a bigger company with engineering offices all over the world. We just opened our second in San Francisco, which is about an hour north of our headquarters. And this is a bigger shift in a company than you might think. And it's been really interesting to watch the company and the company culture sort of try to keep up with this, because what I've realized is bigger companies work fundamentally different than smaller companies. Smaller companies tend to work on sort of ad hoc, person-to-person bases. You know, if you need a database, you go talk to Tanya, because Tanya is the one that does databases. And as you grow as a company, these ad hoc systems start breaking down. And they really start breaking down once you can no longer rely on being able to like walk down the hallway and talk to whoever it is you need to talk to. And so what you start having to do is you start having to replace people with systems and with processes. This just intrinsically sounds bad, right? Like people with systems. It brings up like bureaucracy and enterprise and corporate and all that kind of stuff. And like none of our stereotypes of big companies are good. At least I couldn't think of any. I mean, these are the ones I could think of. You know, people who work for big companies are unhappy because, you know, big companies do mediocre work, because their company is, you know, their company culture is stagnant and doesn't innovate. And this kind of concerned me as a, you know, employee of the company, and I got to wondering whether this was true, and, you know, if it was inevitable, and how does this happen, and can you fight it? And you know, I love that. I'm sure it's fine. I have kittens. He's fine. So, like any true big, you know, nerd, I got really, really into this topic, and I started doing like reading and research, and I read like a bunch of management books, like 90% of which are terrible. And okay, so without getting an MBA in the topic, as far as I can tell, the answer to this question is basically it depends. And what it depends on is how well you design those systems. Are they fair? Are they equitable? Are they just? Are they timely? Can you get a database without updating the JIRA ticket like 9 times and escalating 3 times? So things like that. And if there are problems, do they apply to everybody equally? So I was like, all right, cool. This is kind of hopeful. All right. And as I was doing this reading, like I had this epiphany that, you know, what I was looking at was, you know, doing at large, scalable, fault-tolerant systems of people. Like that's what you do with scaling a company. Like this is what you do. And I was like, wait a minute. This is engineering. And it's engineering from people who aren't engineers, from strangers, in a domain that engineers don't work in, people. And I've heard it said, and I would agree with this, is that the hardest problem in computer science is not naming or cache invalidation, it's people. And so I got really interested in this topic because, if I'm not good at something, I want to learn more about it. And like any good sort of research topic, it grew and it grew and it grew, and I got into all these other fields and all these other things I learned about. And it grew on from corporate culture to just sort of, how to be a better engineer. So Van talked this morning about, Python being able to learn from other languages. And, I kind of got to the point where I realized that engineers can learn from other disciplines too. So that's sort of what I want to talk about, better engineering through not doing engineering, lessons from these other things. And no joke, this has actually changed how I approach engineering problems and what it means for me to do meaningful quality work. So, for example, I came across this study, and this is Teresa Amabile, and she is a professor at the Harvard School of Business. And she studies the question that I was looking at, which is, how do positive and negative work environments happen? And so she got interested in this question, which seems kind of silly, but it was, what makes people happy at work? And you would think people would have asked that before now, but apparently not. And so she did this study where she got people in various companies from various different industries to basically keep a journal of what had happened that day, for a daily journal of what had happened and how they felt about it. And at the end, she had something like 12,000 journal entries, and she and her team correlated them and scored them and tried to look for patterns. So if you had a good day at work, what had caused that? And she found a very definitive result. If you have a good day at work, there is a 75% chance this one thing happened. And I'm actually curious if anybody can guess it. If no cheating, if you've read her book, can anybody guess what that might be? I can't hear any of you. Brains? Praise, okay, praise. No, that's not it. What?
It just works.
It just works. Yeah, all right. That's close enough. Okay, it's close enough. So all right, I'm gonna drop some truth on you here. So are you ready? All right. People are happiest at work when they can get their work done. Right? It seems really stupid. Apparently, the secret to happiness at work is walking in the morning, making meaningful progress on something, and walking out feeling a sense of achievement. Right? Who would guess? It seems dumb, right? And what was interesting is she kind of thought the same thing, the professor doing the study, and she's like, this seems a little obvious. And so she did this other survey where she asked managers this time, what contributes most to your employees' happiness? And so the first four are classic manager, motivators for employees: money, recognition, team camaraderie, clear goals, and at the end, she put meaningful progress on work. Okay, stupid. Nobody here was surprised at this result. Everybody should pick this, right? Would anybody like to guess what percentage did? 2, a little higher, but yeah, 5%. 5%. MBAs don't teach this. Managers are not taught to do this. Even though everybody I've told this result to has reacted like I've told them the sky is blue. Duh. So the first lesson I really took out of this whole thing was, wow, you can be trained out of seeing the obvious. I mean, it's funny to pick on managers, but as a class, they are not in general stupid, and they were employees at one point, and whatever. And then I got to thinking whether there wasn't a deeper lesson in here for engineering. I mean, after all, we're makers, right? People use our work to do their work. We use our work to do their work. And if getting work done is happiness, there seems to be something we could do about that there. And it's interesting, and like as an industry, we are obsessed with performance. Like code performance, network performance, time complexity. If you don't understand big O notation, you are not getting a job at various Silicon Valley industries. Like we think about this all the time. But what I don't hear about a lot is like human time complexity. What is the average time it takes an engineer to get up to speed on your code base? How does that compare to other code bases? What's the queries per day on Stack Overflow for this particular language? How does that compare to other languages? We don't talk about that. We don't think about that. I haven't heard anything about that. And I think one of the reasons for that is that we can't get those metrics. Like, those are magical metrics unless you install a chip in everybody's brain. You know, eventually that may happen, but you can't, if what you can't see, you can't fix. That's an adage there. So I think that's part of it. But I think the other part of it is, this is, traditionally been seen as sort of the domain of like user experience and user interaction. And before I started doing these research, like I would have agreed with that. Like, I'm an engineer. I make it work fast, make it work reliably, and I ship it. That's what I do. And making it pretty, making it easy to use, that's for the art majors. They're good with people. Like let them be good with people, and let me do what I'm good at, which is shipping code. And then I got to wondering if that was true. And that led me to this guy. This is Don Norman, and he's considered one of the founders of user interface design. And he wrote this seminal book on this topic called The Design of Everyday Things. And it's not a new book. It was originally published in 1988, but I found out about it because last year in 2013, it got a 25th anniversary update. And one of my inspirations in the industry, Kathy Sierra, tweeted about it and called it, one of the books that every engineer should read. And so I bought it, and it has changed how I see engineering. And if you get nothing else out of this talk, if you're asleep in the back, wake up for like 2 seconds and remember to read this book, because it has really made an impact on what I do. Because what it taught me really is there's no magic to design. Like, it's not this sort of mystical thing like art, whether you're good at it or not. It's a process, and you can get better at it. And you can get better at it by remembering, I'm going to massively oversimplify here, but there's basically one rule to design. And it's nobody wants to use your stuff. They want to have used it. And nobody buys a drill because they're a drill enthusiast and they, oh God help me, the internet being what it is, I'm sure somebody is, but, you buy a drill because you're not buying a drill, you're buying a hole in the wall, right? Or even that, you're buying a hole in the wall so you can, hang bookshelves so that you can make your house look nicer. And so your job as a designer is to make the time between something starting to use your stuff and then moving the hell on to be as small as possible. You get out of their way. And he talks a lot about doing this. And he gives some examples of like steps you can do. So he talks about when anybody picks up a new thing, they basically ask themselves 2 questions. What is this? Oh, it's a Python module for HTTP. And then what can it do? Get, put, post, delete, cookies, sessions, whatever. And your job as a designer is to make these answers as obvious as possible, as self-apparent as possible, and as quick as possible to answer. So Don doesn't talk about this, but I looked at those 2 questions, and I had a thought. And I'm pretty sure most engineers, software engineers, had the same thought, which is they looked at those 2 questions and said, that doesn't look hard. I can do that in one thing. That's just documentation. You write down what it is, you write down what it does, Move on. Done. Okay, where is the documentation? Is it accurate? Is it complete? Is half of it on the wiki and half of it on the Sphinx server that the one guy who liked Sphinx wrote and maintained and has now moved on from the company? Not that I'm talking from experience here. And so I'm not saying documentation is irrelevant. That is not what I'm saying. But one of the challenges is, can you make it work without documentation? Can you make it so obvious to use? And one of my other inspirations in the industry, Kenneth Reitz, who wrote the request library, talked about how he used this when he wrote the request library. And he said, basically, if you have to refer to the documentation every time you use a module, make a new module. And like, request is a great example of that. Like, it's been probably, I don't know, 3 or 4 months since I've used it. I could probably just write code in it right now without looking up anything. And what he said is, get the API right. How people interact with your module, or your tool, or your software, or whatever it is you use, or your class structure. It doesn't matter. Get that right. And everything else will follow. Performance, features, whatever. You can work on that later. Get the API right first. Because, basically your users have better things to do. Let them. I know you spend all the time working on your code, and it seems really weird to get people out of it as fast as possible, but, that's what you do. And nobody comes into this industry wanting to make terrible code that people work around and, complain about on blogs and things like that. That's not what you do. And as I've started incorporating this philosophy into how I do engineering, the thing is, it's actually really easy to do this. You really only got to do like 2 things. It's not even that hard. All you got to do is you ask and you listen. Hey, can you look over this class structure? Do all these functions make sense to you? Hey, can you sit down for me for 5 minutes and use this new command line tool that I wrote, and I just want to watch you use it and make sure it makes sense. You learn a lot that way. You learn your assumptions are wrong, that what's easy for you is not easy for everybody else. And really, you can spend 10, 15, an hour on this, and it makes a huge, huge difference. Okay, so why don't we use this? This is 30-year-old research. Nothing complicated. It's not like cache invalidation, right? And part of it is this attitude, whatever, lady, I gotta ship code, they'll deal with the bad interface. It's fine. Don't worry about it. But I think there's more to it than that. And I think this goes back to sort of the culture thing I got interested in. I think we just don't value this as an industry. And as a culture. We ask each other code performance and, big O notation on things, but not how complicated and how long it took an engineer to get their last code base, things like that. Okay, so if that's true, if this is, if this is just an industry, if this is a culture thing, how do you change a culture? Can you change a culture? And Don Norman talks a bit about this in his book, but I got into another rabbit hole. Seems to be kind of a thing. And I came to this guy, and this is Patrick Hudson, and he is a professor at Delft University, and I hope I said that right, in the Netherlands. And he is not a software engineer. He does not work in software. He works in the oil and gas industry and the commercial aviation industry. And he wrote this 30-page white paper that I found, which I will tweet out. It doesn't take very long to read. I think all of you would probably find it really interesting. It's very, very readable. And he writes about basically the evolution of safety culture in those industries. Which sounds a little oxymoronic, right? Oil and gas industry, it may surprise you, is not known for safety and ethics in general. And But he actually also works in the aviation industry, and I actually found that interesting because we think of aviation as like the safest way to travel. That's how we talk about it, and that's true for passengers. So I hope you can read this. This is data I took off of the U.S. Bureau of Labor Statistics. It's lost work days per 100 workers. Lost work days due to injuries, illnesses that are due to work. And they track it by industry. So chemical manufacturing is 2.3. Steel manufacturing is 3. Industries we traditionally think of as, very, very dangerous, like construction and mining are like 4. And then we get to air transport. 7.4, like twice as much as mining. And just to give you something to compare it to, like I tried to think of the most dangerous thing I could think of, and that was firefighting, and that was 11. So, air transport. And so in the white paper, he talks about this sort of evolution of how safety works in these industries. And he talks about how it starts, which is the traditional way of these companies looked at safety was, it's a dangerous job. People get hurt. We don't like people to get hurt, but, personal safety is very important, and it's only illegal if you don't get caught. And so the problem with this in general is, things happen and things explode, and if you explode a whole lot of people, then generally other people notice, and some of them may have regulatory authority over you, and and then regulators are pounding on your door and wanting to do stuff like that. And so he talks about the evolution of how the industry has reacted to being regulated. And so attempt number 1 that they tried was, okay, things explode. Let's make less exploding things. Like, we'll make them more reliable, we'll make the machines out of better steel, maybe put some safety interlocks in there somewhere, things like that. And this works. It works just fine. But the problem with this is basically people. And you're not allowed to science your employees. Like that's sort of not a thing you're allowed to do, at least right now. And people make mistakes. They run things longer than they should. They don't quite follow the rules, or because oftentimes they're encouraged to not follow the rules to make more money and things like that. But people will use things in a way they're not intended to, and somebody will screw up and explode. And so again, regulators come knocking on your door and asking why you don't train your employees better. And so the attempt number 2 was, okay, great. We will make a manual of everything that could possibly go wrong. Here's your 850-page manual. Read it and memorize it, including the parts that if you may only do maybe once in your lifetime, and if you don't do them instantaneously, things will explode. Stuff like that. And this was about as effective as you might think. And Patrick, in his white paper, has this great sentence. I love this so much. It's very pithy. And he calls these bureaucracy things, he calls them management systems. And he says about them, management systems are primarily rational inventions, defined on paper in offices, and capable of objective evaluation in audits. They're only good for covering your ass. And so they don't work. And so, the oil and gas industry and the aviation industry have a very well-deserved reputation for, not caring about safety and not really being concerned about that. I'm not saying they're great people in general, although I'm not saying they're bad people, but whatever. But, he talks about there was this movement in these industries of, they are made up of people who don't generally like to explode, and they don't like seeing their friends explode, and their PR people don't like seeing the company on the news for exploding people. So they started wondering, okay, how do we actually be safer? Like, how do we actually do this and not just cover our ass with this? So they kind of moved to acceptance, and this was really interesting to me. And they accepted that people are going to screw up. They have free will and opinions. Nobody wants to read the 850-page manual. But most people want to do the right thing, and they don't want to explode. And the solution that they came up with is they had to tackle the hard problem of how do you change the culture? How do you make sure that people do the right thing when the boss is not looking at them, or when the boss encourages them to do things that are not safe? How do you make sure that they can say no in a way that's reasonable? And I ended up finding this other paper by this company. It's a UK company called Bristow Airlines. They're a helicopter aviation company, or airline company, I should say. They service, I think, the oil and gas industry in the North Sea, and they do search and rescue and things like that. And they published a paper on how they tried to roll out safety code, how they try to change the company, the culture at their company. And they said basically, we believe to influence culture, you need more than just management. And they sort of delineated between, management and leadership. Management is, how many widgets do we have on site so we can ship out next week? Or what's our headcount like? It's around logistics. And leaders drive culture. They're the ones that people follow. And they're the ones that people look to when they do things. So what they did is they had this target zero of I think it was 0 casualties, zero complaints was 1, and 0 lost work days. And they said, okay, we actually want to make this happen. And so what they did was they basically crowdsourced it to the whole company. Each team was responsible for safety. They were responsible for looking at the root cause for accidents and iterating and making sure next time that thing wouldn't happen and moving on this. And I found it really interesting, as far as I can tell from reading all of the stuff that they have, is they actually succeeded in this. And they had an 88% decline in lost work days. And in 2013, they put out this very proud PR statement that they had achieved 0 incidences. And so what was really interesting to me was this culture of safety, going through the industry. So if you thought that 7.4 lost workday was bad, wow, you should have seen it 10 years ago or 5 years ago, And what I took out of this was that culture can be changed, because if these guys could do it, if the oil and gas industry, giant mega conglomerate corporations, that have a well-vested interest in making as much money as possible, if they can do it, we can do something. We can change our culture. We can, make our code more reliable, more fault-tolerant, more friendly towards people. We can make it better, and we can do this. So I want to make this a thing. This is a thing I want to do. I know this costs time and money, and I know this is something that not everybody wants to do, and that's fine. I can find all kinds of blogs and books on how to scale a server, and a lot of people don't need to do that either. Best practices here are scarce. I want to see human design patterns. I want to see books. I want to see blog posts. I want to start hearing buzzwords that random people will endorse you for on LinkedIn that you haven't worked for in 4 years, and they have no idea what you're up to now these days. I want to see that. And all of us are potential leaders as engineers. Most of us don't run companies or do things like that, but a lot of us have leadership over teams or products or maybe just even features or conferences. And we have, we basically have let's see how I can put this. We're paid to have opinions professionally. That's what we do. Like, we're paid to have opinions. And we can move things. We can change culture for this. And so what I want is to make stuff that's loved and awesome for people and not just tolerate it. So, thank you very much.
Thank you, Rachel. We have about 15 minutes left if anybody wants to ask a question. Jonathan. Oh, have you got you have to kind of really make sense of it.
Does it work? Okay.
Thank you for that. That was great and very inspirational. My question is, so do you have personal or other examples of projects or things which you think are doing a good job in that direction? To try and make it like more concrete, you know what I mean?
More concrete, yeah. The most examples I have, unfortunately, are at LinkedIn and I can't actually talk about them. I can say a little bit about it. So one of the projects that I worked for is basically a hiring application that LinkedIn uses internally, and it's used across the company. And those systems generally are terrible. Like, all HR systems are, like, without exception, terrible. And so we wanted to make one that wasn't terrible because everybody in the company uses it. And so we spent a lot of time, like, talking to other engineers, talking to people who used it, iterating on that, and treating, like, problems as bugs, for example. And I've seen that more in the sort of the negative side, where our toolkits, and people like struggle with toolkits and making sure, like, how to like packaging, like how do you package Python application, things like that. So yeah. Thanks. Yeah.
Okay. Yeah, over there.
Thank you for a great talk.
Yeah.
I have a question about the first author you mentioned and his book. Could you please repeat his name and the book?
Oh, yeah. Which one?
The first one. I didn't quite get it.
Oh, I don't have it here. I'm sorry. I have it. Sorry about that. It's Don Norman. Sorry there. Yeah. It's Don Norman. The Design of Everyday Things. Is that what you were talking about? Yeah.
Oh, thank you. Maybe just another mention.
I'll tweet it out too. Like, if you follow that, I'll tweet it out.
Maybe I can recommend one more. Alan Cooper.
Alan Cooper?
Alan Cooper, yes. He has great books about face, and the short version, The Inmates Are Running the Asylum. That's a great books about usability and the engineers and how they write their code. Thank you.
Yeah. Tweet them to me, and I'll tweet them out so people can find them too.
Okay, thank you.
All right, if we've got one more question at the back. You start making your way towards me, I'll make my way towards you.
Thanks very much. In the industries you mentioned, like aviation and the gas industries and so on, everyone whom you need to rely on to do the right thing is at least already in the industry, is buying into the training and these ideas because they're actually at the sharp end of it. Whereas we in the software industry have users who are not buying into anything, and they are the most diabolical people in the world, and they will invent things that even the most zany pilot or gas pipeline technician would never dream of doing. So we can't rely on them to be joining in with us. We don't want to be. We have to be constantly on the alert for them, as we would with young children or wild animals. And that's an extra step. That makes it extra difficult for us, isn't it?
Yeah, I understand. Like, users will often lie to you. They'll say, like, "Oh, this is really important." So you listen to them, but like the other is you ask and you watch what they do, and so it also you look for patterns. Like I don't talk to just one person. When we spun up a new project and we were trying to automate something like basically creating a new database, which normally took 2 weeks and like 3 SREs to do. So we went around and we asked a bunch of people like what actually takes the most time, and you get a variety of things, but like statistically they sort of cluster, and so you kind of look for clustering. I mean, obviously you're an engineer, you use your judgment, and then also look for just problems and look for areas where things are just rougher and people have trouble with, or bug reports are often a good one. This doesn't work. If the problem is between the computer and the chair there, and look for those, because those are often a place where there's like cognitive problems going on with whatever it is your tool. So some of it is judgment, but as a first cut, you can just ask. It's if you really want to get down into like doing this really, a lot, but yeah, you can make a good first cut at it that way.
Well, I think Jonathan, did you have a question?
Yeah, it's more common. I read a book, Psychology of Computer Programming.
Oh, yeah?
By Gerald Weinberg in 1972. And it's a very good book. He, for example, talks about pair programming, although he doesn't use that phrase. And he addresses a lot about what causes programmers to make mistakes. So I highly recommend that book.
Yeah. There's a whole chapter in the Design of Everyday Things about human error and basically like, the problem of like fat fingering and like taking down servers, and how we tend to blame ourselves for that and not the systems that allow us to take down the server. And I didn't have a chance to integrate that into the talk, but it's definitely worth reading. It was a very interesting field. I got it, about it.
Well, thank you very much.
Awesome, thank you.
So, I'd like to have take a quick moment to ask the speakers of the next talk to give a 1-minute explanation of what their talk is about. So Mark, who's already come here.
Yeah, just a second.
You give it like a 30-second plug of what you're talking about.
So I'm going to talk about performance, but on a very kind of different scale. I'm going to look at various different things that you can do in Python and how to improve your code with very little changes and make it run faster.